Okay, my name is Nurada binti Muhammad Syabri, and I supervised by Dr. Eddie Rozi bin Abdul Manaf. My project title is Comparative Study of Heat Treatment Defects on Spring Steel. Okay, the introduction is heat treatment is the process of heating and cooling of metals to change their physical and mechanical properties without changing its shape. 50 CRZ for spring steel is a tough, shock-resistant, shallow-hardening chromium vanadium steel having high fatigue and impact resistance in the heat-treated condition. It is used extensively in gears, pinions, springs, shaft, axles, pins, bolt, and etc., which require high modulus of resilience. Okay, the problem statement is heat treatment is performed to spring steel in order to change their properties without changing its shape. Heat treatment can cause the defects of the spring metals. The defects will cause the major problem when the heat-treated defects parts are used. The defects itself occur due to variety change in temperature and time. Okay, the objective is to hypothesize the effects of heat treatment on the mechanical properties and structure of 50 CRV for spring steel. To suggest the second objective is to suggest the relationship between the processing parameters such as temperature and time to the physical and metallurgical defects of 50 CRV for spring steel. Third objective is to correlate the hypothesized properties of the heat-treated 50 CRV for spring steel with the morphological and metallurgical properties based on previous data. Okay, the scope is firstly the 50 CRV for spring steel is used for the heat treatment process to detect the defects occur during the process. The material is cut to the small pieces specimens. The specimens were subjected to hardening at 860 degrees for 1.25 hours and oil quenching to room temperature, followed by tempering at 4 different temperatures of 2 different conditions of temperature, which are 250, 300, 370 and 450 degrees Celsius and 400 degrees Celsius, 450, 500 and 550 degrees Celsius for 3 hours each with oil quenching to room temperature. The sample will be characterized for their mechanical and physical properties as well as morphological analysis. Okay, the literature review I take from the 3 journals, which are heat treatment studies on 50 CRV for spring steel by V. Anil Kumar and his friends. Okay, they examine the 50 CRV for spring steel to the heat treatment processes. They use transverse mechanical properties have been evaluated. They examine the 50 CRV for spring steel to the heat treatment processes. Okay, the second is fracture toughness of the vacuum heat treated spring steel 51 CRV4 from Bojan Senvic and his friend. They use a Chaffee V notch impact test value in toughness specification for spring steel, even though the fracturing energy is not directly related to the spring design. They use the testing method using circumferentially notched and fatigue pre-cracked tensile specimens. Okay, the last is effect of heat treatment on microstructure and mechanical properties of spring steel from Min-Shan and his friend. The tempering time and temperature, hardness, and ultimate tensile strength are gradually decreased and ductility was improved. Moreover, Rather, interesting condition is observed in elastic properties. An endurance limit at 450 degrees Celsius and 1 hour tempering condition, and this state is the optimum condition for spring production. Okay, the methodology is start from the specimen preparation, which we cut the material to the small pieces. Then we test the composition analysis through the materials. Then we go to the heat treatment process, which start from austenizing process, which is 870 degrees Celsius in 1 hour. Then we annealing, quenching, and tempering. Tempering, we have four different temperature, which are 400 degrees Celsius, 450 degrees Celsius, 500 degrees Celsius, and 550 degrees Celsius. Then we conduct the test. Then we use the mechanical testing, hardness test, which is hardness test and tensile strength, and the microstructure observation, which are the structure of the material after the process. For the result and discussion, I use the results from the previous data. And for the mechanical properties, for this ultimate tensile strength, I use from the Hitchum mentioned from an inch strength. It shows that a decrease in ultimate tensile strength (UTS) with the increase of temperature on heat treatment process. From my observation, the ultimate tensile strength slightly decreased at 300 degrees Celsius with 1,810. The ultimate tensile strength (UTS) is found to decrease with the increasing in tempering temperature. This is attributed to coarsening of tempered carbides. For the percentage elongation, I took from the same journal, same report. It showed that percentage elongation increase as the temperature of heat treatment increase. So my expected observation, the percentage elongation values are typical of transverse direction testing of ultra high strength steels (UTS), and it is in line with earlier work. So as the tempering temperature increase from the 370 to 450 degrees Celsius, there is drastic drop noticed in UTS to the tune of the from the interval of 200 MPa with two-fold increase in percentage elongation. So the mechanical properties, I use the hardness. The value of hardness decrease as the temperature of heat treatment increase. So from my observation, the hardness was measured using Rockwell hardness tester in C scale. So the hardness is slightly decreased as the hardness can be attributed to the effect of heat treatment. So the hardening as well as tempering operation were limited to 15 millimeter thickness. So the morphological analysis is the microstructure of oil quench and the water quench. So the both show that the microstructure is martensites and retained austenite. Okay, the morphological analysis show that the magnetic structure of ferrite and epsilon carbide are formed at 400 degrees Celsius and to 450 degrees Celsius for each tempering time. However, the grain size are differ on the quencher medium of oil quencher of oil quenching and tempered. So the overall grain size are much coarser than the water quenching and tempered sample, as the rapid cooling medium, which is water, give the finest and smaller grain size compared to oil. Besides the parameters such as different temperature and time would give the precipitate and ferrite growth are observed. So the growth of the size is observed as tempering temperature and longer tempering time. Okay, there are several defects occurrence which is observed from the microstructure of the sample from oil quench and tempered at different time and temperature. So, but however, there is sample that have no defects on the microstructure. Most probably, the time and temperature are well suited with the characteristic of the sample. So, surface decarbonisation are occurring at 400 degrees Celsius of oil quench and tempered for 3 hours and 550 degrees Celsius for 1 hour. So, decarbonisation occur when carbon atoms at the steel surface interact with the furnace atmosphere and are removed from the steel as a gaseous phase. So the dark spot defects appear on the microstructure of oil quench and tempered at 500 degrees Celsius for 2 hours. So the dark spot corresponds to localized at corrosion mark. Okay, the conclusion is the heat treatment studies have been carried out to develop the heat treatment cycles for spring steels. Transverse mechanical properties have been evaluated. So the second conclusion is the 0.2 percentage. The 0.2% PS is found to decrease with increase in tempering temperature, and this is attributed to the coarsening of tempered carbides. So from the structural point of view, more retained austenite are formed in oil quenching than in the of water. So in tempered process, ferrite and epsilon carbides are formed at 400 to 450 degrees Celsius, and spheroid cementite are formed and grown above 450 degrees Celsius. So my recommendation is to improve this research is the test should also must be added more different temperature and time to obtain the accuracy of which temperature or time that most suitable for the heat treatment process, and the produced sample must be stored in the temperature and humidity controlled cabinet so that the properties of the samples can be maintained better. Okay, that's all from me. Assalamualaikum warahmatullahi wabarakatuh, and thank you.